This is the first equation we learned. Equation of a straight line passing through a point. One point on the straight line is given, that is capital A, and parallel to a given vector. So what is that given vector? Parallel to given vector means what is that given vector? Vector B. Vector B is that parallel vector. So we took the parallel vectors condition. Vector AP is parallel to vector B. And we know when two vectors are parallel, one of them is equal to lambda times the other, lambda times vector B. The lambda is a constant, scalar. Now vector AP is in terms of position vector. How do you write? Vector OP minus vector OA, or vector R minus vector A is lambda times vector A, or vector R is equal to vector A plus lambda times vector B. So what is vector A? It is a position vector of the given point, and vector B is the parallel vector. Vector B is the parallel vector. All of you understood this from online? Is it clear? Response, and your camera.
Yes, sir.
Yes, sir. Please. Okay. So now the Cartesian form. For the same one, we have the vector form and the Cartesian form. For Cartesian form, we take the Cartesian coordinates. Cartesian coordinates are of the form x, y, z. So we take in the same diagram, no need to draw the separate diagram. In the same diagram, we will mark the Cartesian coordinates like this. Capital A, the coordinates of capital A is x1, y1, z1. That means the given point capital A is x1, y1, z1. And capital P is x, y, z. Capital P is x, y, z. Capital A, x1, y1, z1. And capital P is x, y, z. Capital P, x, y, z. Capital A, x1, y1, z1, and capital P is x, y, z. Capital P is x, y, z. Okay. Yes. Then we take like this. Vector R. When the coordinates are given, all of you know, vector OP or vector R is xi cap plus yj cap plus zk cap, right? And vector A will be x1 I cap plus y1 j cap plus z1 k cap. And vector B we take like this. Let the position or direction ratios of vector B be A, B, C. So that vector B we are going to write A I cap plus B j cap plus C k cap, where A, B, C are the direction ratios. The coefficients of a vector are direction ratios. By using these, we are going to write the Cartesian form. So vector B you can write A I cap plus B j cap plus C k cap, vector B. A I cap plus B j cap plus C k cap, the vector B. Okay, so now we write the Cartesian form. Right, Cartesian form. Cartesian form. Let the direction ratios of parallel vector. Let the direction ratios of parallel vector. Let the direction ratios of parallel vector, vector B, be A, B, C. Let the direction ratios of parallel vector, vector B be A, B, C. That is, vector B is equal to A I cap plus B j cap plus C k cap. Vector B is equal to A I cap plus B j cap plus C k cap. Then let capital A, x1, y1, z1 be the given point. Be the given point. Be the given point. And capital P, x, y, z be any point. Be any point on the line. Any point on the line. Capital P, x, y, z. That means we have taken the Cartesian coordinates like this. Given point Cartesian coordinates is x1, y1, z1. Any point is x, y, z. Any point is x, y, z. Okay. So now we can write that vector OP or vector R. Vector R, how do you write, children? Xi cap plus yj cap plus zk cap. Okay, the position vector. In the vector first page of that vector, when I explain the position vector, I have explained this one. If the point P is x, y, z, even the component form also we wrote this. Then vector A, how do you write vector A or vector Y? The same way, vector A. Capital A is x1, y1, z1. Vector A is x1 I cap plus y1 j cap plus z1 k cap. x1 I cap plus y1 j cap plus z1 k cap. Okay, so let's substitute this one to the vector form. Vector R is equal to vector A plus lambda times vector B. Vector R is vector A plus lambda times vector B. And what is this vector R? It is xi cap plus yj cap plus zk cap is equal to vector A is x1 I cap plus y1 j cap plus z1 k cap plus lambda times vector B. Vector B is a I cap plus bj cap plus ck cap. Vector B is I cap plus bj cap plus ck cap. I cap plus bj cap plus ck cap. Is it clear? Yes. Now I take these three terms to the left hand side. These three terms to the left hand side. So I take these terms to the left hand side. So we get x minus x1 into I cap. Clear? Because we take xi cap and then minus x1 I cap also to the left side. So how can we combine this? X minus x1 into I cap. Then same way, next yj cap minus y1 j cap. How will you combine this? Y minus y1 into j cap. Y minus y1 into j cap. Y minus y1 into j cap. And the next is z minus z1 into k cap is equal to lambda a I cap plus lambda b j cap plus lambda c k cap. So after this, we equate the coefficients of I cap, j cap, and the k cap, equating the coefficients of I, j, k. All of you understood this term? Yes. Next is equating the coefficients of I, j, k. Equating the coefficients of I cap, j cap, and k cap. Yes, what do you get, children? X minus x1 is equal to lambda a. X minus x1 is equal to lambda a. Or x minus x1 by a is equal to lambda. Or x minus x1 by a is equal to lambda. Equation number 1. And the second one we get y minus y1 is equal to lambda b, or y minus y1 by b is equal to lambda, equation number 2. And the third is z minus z1 is equal to lambda c, or z minus z1 by, what is that? Z minus z1 by C is equal to lambda, equation number 3. Equation number 3, okay. Now we equate these three because all are equal to the constant lambda, right? All these are equal to the constant lambda. So by equating these three, we get the Cartesian form. So from equations 1, 2 and 3 we get, from equations 1, 2 and 3 we get x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. This is the Cartesian form. X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c is the Cartesian form. All of you understood this? Yes, please write. X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c is the Cartesian form. Done. So here x1, y1, z1 is the Cartesian coordinate of the given point. ABC is the direction ratios of the parallel vector. ABC is the direction ratios of the parallel vector. Okay. In sums, we equate it to lambda also, that constant lambda, and we will simplify in foot of perpendicular image type of questions. Even in a shortest distance, we convert this one to vector form. Okay, we convert this one to vector form in the shortest distance. There, x1, y1, z1, that we write vector A from there, vectoring. x1 I cap plus y1 j cap, and vector R, vector B also we write from the denominators. Is it clear, the first form? Yes. This is the most important equation. One more equation is there, that is 2-point form. In 2-point form, as the name indicates, 2 points on the line will be given. The 2 points we take, capital A and the capital B. Capital A is x1, y1 is z1, and capital B is x2, y2. x2, y2 is 2, and vector B, that will not be there. Parallel vector will not be there. Instead, capital A and capital B, 2 points on the line will be given. So let's write the second form. Second form. Right. 2-point form. 2-point form. Second equation is 2-point form. Two-point form means equation of a straight line passing through 2 points. Equation of a straight line, right? Equation of a straight line passing through two points. Equation of a straight line passing through 2 points. Equation of a straight line passing through 2 points. That is a 2-point form. Equation of a straight line passing through 2 points. Okay, so here let's draw a diagram. X-axis, y-axis, then 2 points on the straight line will be given. X, y and the z-axis, the 3D axis. Then a straight line. A straight line then 2 points on this straight line are given. So let's take the point capital A, then capital B, then let P be any point. Okay, let P be any point on this straight line. Let P be any point on the straight line. Let P be any point on the straight line. Finish. So then we have to join the direction ratios, that is vector OA, the position vector OA. Here A and B are the given points. So the position vector of A is vector A. One more point is given. What is that second point given? B is the second point. So its position vector is B vector. So the position vector of B is small letter B vector. This is B vector. And then OP, we have to join OP. The position vector of P is, what is the position vector of any point? R vector. Like this, we take the three vectors, okay? Vector A, vector B, and vector R. Using this, we are going to write the 2-point form. Okay, did you complete the diagram? And please mark A vector, B vector, and R vector. Last derivation, how do you start vector form? Vector AP is parallel to vector B, right? Vector B. Here there is no such vector B. So here we start vector AP and vector AB are collinear. And all of you know collinear vectors. In vectors, we can use the word parallel as well, right? So we use that. Vector AP is parallel or collinear to vector AB. When two vectors are collinear or parallel, we can write one vector is scalar multiple of the other. So how do you write? How will you write this one? Vector AP is equal to lambda times vector AB, where lambda is a scalar. Now, vector AP is vector OP minus vector OA. So, vector OP minus vector OA is equal to lambda times vector OB minus vector OA. Lambda times vector OB minus vector OA. Lambda times vector OB minus vector OA. Now, what is vector OP minus vector OA? Vector R minus vector A. Vector R minus vector A. So, vector R minus vector A is equal to lambda times vector OB is B vector minus A vector. So, we get the vector form R vector is equal to A vector plus lambda times B vector minus A vector. This is the vector form. Clear? R vector is equal to, it is similar to the last two form. Last two form we got vector A vector plus lambda times B vector, right? Here in place of that B vector minus A vector, okay? This form is called a vector form. So here vector A and the vector B are the position vectors of the given points, That also you can write, where vector A and vector B are the position vectors of the given points. Where vector A and vector B are the position vectors of the given points. Where vector A vector and the B vector are the position vectors of the given points, Clear? A vector and B vector are the position vectors of the given points. This is the vector form. What is the next form? Cartesian form. Next is Cartesian form. Yes. Did you complete the vector form? Finished. Next, Cartesian form. In Cartesian form, we take the Cartesian coordinates. Right, Cartesian form. See, when 2 points are given, how can we write the Cartesian form? So we'll take the points capital A as x1, y1, z1, and capital B as x2, y2, z2. Let capital P, x, y, z be any point. Okay. Let capital P, x, y, z be any point. Capital A is x1, y1, z1. Capital B, x2, y2, z2, and capital P, x, y, z be any point. Okay, so please mark. Capital A, x1, y1, z1. Capital B, x2, y2, z2, and capital B, capital P, x, y, z be any point. P, x, y, z be any point. Okay. Okay, so now we start vector A, vector B, and vector R, but we can substitute. What is a vector A? So let's take like this. Let capital A, x1, y1, z1, and capital B, x2, y2, z2 be the two given points. Be the two given points. Okay, so let these two be the two given points. Be the two given points. Be the two given points. Okay, so then we can write vector A is equal to, what is A vector? What is A vector? X1 I cap plus Y1 J cap plus Z1 K cap, and B, a vector B or B vector, X2 I cap plus Y2 J cap plus Z2 K cap. Then R vector, vector R is Xi cap plus Yj cap plus Zk cap. Okay, so these three we take. So let's take these three. Okay. Okay, so now we will substitute. We will substitute this in the vector form. So what is the vector form? Vector R is equal to 2-point form, vector form. Vector R is vector A plus lambda times B vector minus A vector. This is the vector form in 2-point form, right? So let's substitute R vector. R vector is Xi cap plus Yj cap plus Zk cap is equal to A vector is x1 I cap plus y1 j cap plus z1 k cap plus lambda times B vector is x2 I cap plus y2 j cap plus z2 k cap, then minus of what is that, x1 I cap plus y1 j cap plus z1 k cap. Z1 k cap. Is it clear, the substitution? Yes. Now we will take these three terms to the left side, the same as there in the last one. So let's take these three terms to the left side. Is what do you get, children, if you take these three terms to the left side? These three terms. So let's take these three terms to the left side, and what happens? X minus x1 into I cap plus y minus y1 into j cap plus z minus z1 into k cap. So we get like this, x minus x1 into I cap plus y minus y1 into j cap plus z minus z1 into k cap is equal to lambda times, yes, lambda times what do you get? Lambda times x2 minus x1 into I cap, okay, x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap, which is equal to lambda times x2 minus x1 into I cap plus lambda times y2 minus y1 into j cap plus lambda times z2 minus z1 into k cap. Lambda times z2 minus z1 into k cap. Now let's equate. X minus x1 is equal to, what is that? X minus x1 is equal to lambda times x2 minus x1. So we bring this to the denominator. X minus x1 by x2 minus x1 is equal to lambda. So this step we get by equating coefficients of ijk. By equating coefficients of ijk, we get the first step. X minus x1 is lambda times x2 minus x1. Is it okay? Last question it was lambda times a. And we got x minus x1 by a. It is the same here. Instead of a, it is x2 minus x1. Next one, how do you get y minus y1 is? Yes, y minus y1 is equal to, what is that? Y minus y1? Lambda times y2 minus y1, right? Y minus y1 is lambda times y2 minus y1. Then y minus y1 by y2 minus y1 is equal to lambda. Then z minus z1 is equal to lambda times z2 minus z1 or z minus z1 by z2 minus z1 is equal to lambda. Z minus z1 by z2 minus z1 is equal to lambda. Clear? Okay. Now we equate these three. What do you get when you equate these three? That is x minus x1 is equal to, from 1 to 3 we get x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. This is the Cartesian form of 2 point, if 2 points on the line are given. So this highlighted equations you have to remember. Derivations will not come in the exam. This derivation I explained to understand the concepts very well. Now, when you see a question of this type, you know where is that point, right? x1, y1, z1, x2, y2, z2, and 1. So both the equations are okay. First form, 1 point form. Second form is 2 point form. 2 point form. Yes, these are the two equations, and we have sums based on this. So now let's do the sums based on these two equations. And then after completing those sums, we have a angle between the two lines, and then we have shortest distance. Okay. So please write the question. Find the equation of the line. Find the equation of the line find the equation of the line which passes through the point which passes through the point 1, 2, 3, 1, 2, 3 and parallel to the vector and parallel to the vector and parallel to the vector 3 I cap plus 2j cap minus 2k cap. Find the equation of the line passes through the point 1, 2, 3 and parallel to the vector 3I cap plus 2j cap minus 2k cap. So here, if it is simply written equation, we have to write vector form and Cartesian form. If a form is specified, that form is enough. Okay, so this is 1-point form or 2-point form? 1-point form, clearly 1-point form, right? Passes through a point. 1 point is given and parallel to the vector. That vector B is also given. Okay, so first of all, we are going to write vector form and then we are going to write the Cartesian form. For vector form, yes, those who understood the derivation can easily figure out vector form. Do you remember what is a vector form in 1 point? Vector R vector is equal to A vector plus lambda B vector. So we have to write A vector and B vector. A vector we write from the point. The point is 1, 2, 3. So how do you convert it into position vector? 1I cap plus 2j cap plus 3k cap. Okay, like this it is so easy if you understood the derivation. So we write A vector is 1I cap plus 2j cap plus 3k cap or I cap plus j cap plus k cap, A vector. Then B vector is, what is B vector? 3I cap plus 2j cap minus 2k cap. 3I cap plus 2j cap minus 2k cap. Is it clear? Then we substitute. R vector is equal to A vector plus lambda times B vector. So that is equal to I cap plus 2j cap plus 3k cap plus lambda times 3I cap plus 2j cap minus 2k cap. This is the vector form. Clear? This is the vector form. Got it clear? Okay, yes. But is it enough? No. Cartesian form. When if the question is asked, find the equation, means we have to write both vector form and the Cartesian form. Vector form, all of you finished till here? Yes. Now Cartesian form. For Cartesian form, yes, just recollect the Cartesian form. Cartesian form is x minus x1 by a, y minus y is equal to y minus y1 by b is equal to z minus z1 by c. For that we write x1 y1 z1. What is x1 y1 z1? x1 y1 z1 is the point 1, 2, 3. Then direction ratios of that parallel vector, we write ABC. What is ABC? Coefficients of that parallel vector, that is 3 to minus 2. Clear? It is not in bracket, it is direction ratio, it is not coordinate. So like this, or 3 is to 2 is to minus 2. Then we substitute. So x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. That is x minus 1 by 3 is equal to, what is that? Y minus 2 by 2 is equal to z minus 3 by how much? Minus 2. This is the Cartesian form. Is it clear, this question? It is a 2-marker type of question. Okay, so I'm going to give you a similar question. You will try that. Instead of that point, position vector can be given. 1 I cap plus 2 j cap plus 3 k cap. That doesn't matter. You can easily convert it into point, right? Yes. Now write the next one. Yes. Hope you all finish. Find the equation of the line. Write the question. Find the equation of the line find the equation of the line which passes through the point with position vector 2 I cap minus j cap plus 4 k cap and in the direction of I cap plus 2 j cap minus k cap. I cap plus 2 j cap minus k cap and in the direction of I cap plus 2 j cap minus k cap. I cap plus 2 j cap minus k cap. Okay. So please write. Find the equation of the line which passes through the point. Means vector A, right? Vector A is there. This is vector B. You have to write vector form and the Cartesian form. Can you try this one? This is also 1.4 or 2.4? 1.4. Okay, please try. Yes, did you complete this one? This is a 1-point form. So here, vector A is the position vector of the given point. So first of all, we write vector form. For the vector form, vector A is equal to 2i cap minus j cap plus 4k cap, and vector B is I cap plus 2j cap minus k cap. Okay, so then we write the vector form like this. Vector R is equal to vector A plus lambda times vector B. So that is 2i cap minus j cap plus 4k cap plus lambda times vector B. What is vector B? I cap plus 2j cap minus k cap. This is the vector form. All of you got the same answer? Yes. Online, your response, please. You all got the same? Online?
Yes.
All of you got the same. Vector form, you got the same, right? Yes. Next is Cartesian form. For Cartesian form, we write the Cartesian coordinates. Laksharaj, finish. Next, Cartesian form. In Cartesian form, we write the point x1, y1, z1. Can you tell me what is the point x1, y1, z1 from the position vector? 2 minus 1, 4. It is the coefficients, right, of that vectoring. 2 minus 1, 4. Then we write direction ratios of the parallel vector. It is A, B, C. That will be the coefficient of vector B. What are coefficients of vector B? 1, 2, minus 1. This one you should not put in a bracket because it is not ordered triplet. Okay, it is simply the direction ratios. Then we write the Cartesian form. What is Cartesian form? X minus x1 by A is equal to plus y1 by B is equal to z minus z1 by C. That is x minus 2 by 1 equal to y minus minus 1. Y plus 1 by 2 is equal to z minus 4 by minus 1. Z minus 4 by minus 1. Clear? This is the Cartesian form. Okay, got it. Next one. Find the equation of the line. Find the equation of the line find the equation of the line which passes through the point which passes through the point which passes through the point minus 2, 4, minus 5, which passes through the point minus 2, 4, minus 5, and parallel to the line x plus 3 by 3 is equal to y minus 4 by 5 is equal to z plus 8 by 6. X plus 3 by 3 is equal to y minus 4 by 5 is equal to z plus 8 by 6. Z plus 8 by 6. Okay. Find the equation of the line which passes through the point. Means one point is given, x1, y1, z1, or we can write vector A from there, right? Parallel to the line means we have to see the direction ratios of that parallel vector. Direction ratios of parallel vector we get from the denominator because denominator is x minus x1 by A, right? So these are A, B, C. When two vectors are parallel, their direction ratios will be either equal or proportional. we studied in vectors. Lambda times means proportional. So we can take the same direction ratios or proportional. So proportional means when we simplify it will be the same. So what is ABC? ABC will be 3, 5, 6. Is it clear? Now it is similar to the last question. Okay, so we write. So from here, first of all, we write vector form. For the vector form, first of all, we look at the point and convert it into position vector. So A vector is minus 2 I cap plus 4 j cap minus 5 k cap. This is A vector. Minus 2, 4, 5, minus 5, this one. Not from here. Not from that parallel vector, we don't take the point. Point is given separately. From parallel vector, we take the direction ratios of parallel vector, only that, okay? So is it clear, this writing? Then B vector from the denominators of that parallel vector. So what is that B vector? 3 I cap plus 5 j cap plus 6 k cap. 3 I cap plus 5 j cap plus 6 k cap, okay? 3 I cap plus 5 j cap plus 6 k cap. All right. So then we substitute R vector is equal to A vector plus lambda times B vector. That is, R vector is equal to minus 2 I cap plus 4 j cap minus 5 k cap plus lambda times 3 I cap plus 5 j cap plus 6 k cap. This is the vector form. R vector is A vector plus lambda times B vector. Clear? Next is Cartesian form. Cartesian form. Cartesian form is, for that we write x1, y1, z1. x1, y1, z1 is the point. That point we just copy. It is minus 2, 4, minus 5. Minus 2, 4, minus 5, okay. And then ABC, okay. What about ABC, the direction ratios of that parallel vector? 3, 5, 6, 3, 5, 6, 3, 5, 6. Is it clear, this writing? Then you copy the, write the Cartesian form and substitute. What is Cartesian form? X minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C. That is x minus minus 2 by 3 is equal to y minus 4 by 5 is equal to z minus minus 5 by 6. Or we get x plus 2 by 3 is equal to y minus 4 by 5 is equal to z plus 5 by 6 is the Cartesian form. This is the Cartesian form, okay? Right. Next, Cartesian form will be given. This form will be given. Write the vector form. It's so easy. If you get Cartesian form, you have to write in standard Cartesian form. What is that? X plus 2 by 3, if it is given, coefficient of x must be 1. Then x minus minus 2 by 3. Y minus 4 by 5, z minus minus 5 by 6. And from there, we separate out the point x1, y1, z1, minus 2, 4, minus 5. And from there we can write vector A, right? And from the denominators, we write the direction ratios. And using direction ratios, we write vector B and substitute in vector form. Other way around also can be asked. The vector form will be given and to write the Cartesian form. Okay, so please write the type of 2 questions from Cartesian form to vector form. The Cartesian equation of a line is, right. The Cartesian equation of a line is the Cartesian equation of a line is two x minus 4 by 6 is equal to 3y plus 5 by 7 is equal to z. Write its vector form. Write its vector form. Write its vector form. Cartesian equation is given. Write its vector form. So this Cartesian equation is not exactly the same standard form. Right? What is the standard form? X minus x1. Coefficient of x is 1. And then after that minus. So first of all, we have to take this 2 outside, because coefficient here it is 2. And here 3 outside, 3y plus 5. When you take a common factor outside, means we divide both the terms by that common factor. That is the first step. So in the first term, you will take 2 outside and we write 2 times, what do you get? X minus 2 by 6 is equal to 3 times, yes, 3 times, what is that? Y plus 5 by 3 by 7 is equal to Z. Now 2 and 6 will go, 3. So x minus 2 by 3, that part is okay, standard form we got. And second term, 3 and 7 we cannot cut. So, but we have to write the form y minus y1 by b, right? So to manage that, we take 3 to the denominator. So 3 as the denominator of 7. That means we write this as 7 by 3. And the numerator we write y minus 5 by 3 by, how will you write this one? 7 by 3. Is it clear? Now we got y minus y1 by b. All of you understood this? Okay, y plus 5 by 3 we write y minus 5 by 3, because the standard form is y minus y1 by b. Here in place of b, it has to be 7 by 3, because there is a coefficient. We can't cut these two. So what to do? We take 3 as the denominator of 7. Now this is on the form y minus y1 by b. Now is equal to z. How to? Z by 1. Z minus 0 by 1 is the correct form. Z by 1. But to get that Z minus Z1 by C, how will you write? Z minus 0 by 1. Now compare it with the standard form. Is it okay? Standard form, right? Yes. So from here, the point x1, y1, z1. The point x1, y1, z1 is 2 minus 5 by 3, 0. And from there we can write vector A. What is vector A? 2 I cap minus 5 by 3 j cap plus 0 k cap. This is vector A. Okay. Now vector B we write from the denominator, that is 3 I cap plus 7 by 3 j cap plus 1 k cap. So we got vector A and vector B. Now can you write the vector form? doing easily. So what is the vector form? Vector form is vector R is equal to vector A plus lambda times vector B, which means 2I cap minus 5 by 3 j cap plus 0 k cap plus lambda times 3I cap plus 7 by 3 j cap plus k cap. So this is the answer. Okay. This is the answer. Clear? Next, one more question of the same type, but a slight difference, converting Cartesian form to vector form. Yes, please write. Cartesian? Oh, Cartesian form to vector form. One more question of the same type, because that form mostly asking which one, Cartesian form to vector form. Vector to Cartesian is very easy, because directly that is there. So we can easily write. Now write one more question. The Cartesian form of a line is, Cartesian form of a line is x minus 1 by, x plus 1 by 3 is equal to y minus 2 by 1, then semicolon or comma z is equal to 2. Semicolon or comma z is equal to 2. Yes. So this one we have to connect it to the main part. That is our task. First two terms are okay. X plus 1 by 3 means x minus 1 by 3. Second term is also fine, standard form. But how will you connect it to the other unit? All of you know? Yes, I'm coming to that point. So this one we connect like this. Z is equal to 2, we can connect like this. Z minus 2 by 0. If we equate it to lambda, because other two are equal to lambda in the derivation we studied, other two terms are equal to lambda. Okay. If I equate like this to lambda, will we get Z equal to 2? Yes. So its corresponding form is Z minus 2 is equal to lambda into 0. What is lambda into 0? 0. So then Z is equal to 2. So this is the correct connected form, Z minus 2 by 0. Okay, so like this comma Z is equal to 2 or semicolon Z is equal to 2, we connect to the main part like this, Z minus 2 by 0. Understood the logic behind that one? Clear? Z minus 2 by 0, when we equate to lambda, Z minus 2 is lambda into 0, that is 0. Or Z is equal to 2. Clear? Yes, please note down. Okay, so now we connect it to the main part. X plus 1 by 3 can be written as x minus 1 by 3 is equal to y minus 2 by 1 is equal to Z minus 2 by 0 is equal to Z minus 2 by 0. Z minus 2 by 0. Clear? Okay. Which means we got that standard form, right? Yes. Now we can write vector A. What is vector A from here? Minus 1 I cap plus 2 j cap plus 2 k cap, right? Vector A we write from that point, minus 1 I cap plus 2 j cap plus 2 k cap. And vector B we write from the denominator, 3 I cap plus 1 j cap plus 0 k cap. because y minus y1 is 2. After minus sign, we get y1. y1 is 2. Is it clear? So that is plus 2. But here see x plus 1. We have to write x minus minus 1. So it is minus 1 I cap. Then we write a vector form. Write its vector form in the question. And don't write that one. Write its vector form. Write its vector form. That is there as part of question. So we write vector R is equal to vector A plus lambda times vector B. That is vector R is equal to minus I cap plus 2j cap plus 2k cap plus lambda times 3I cap plus j cap. Okay, so this is the vector form. This is the vector form. Next term. 2-point form based a question. 2-point form, vector R is vector A plus lambda into vector B minus vector A, or x minus x1 by x2 minus x1. In place of A, it is x2 minus x1. Y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. So write a question of that type. Find the equation of a line. Find the equation of a line find the equation of a line which passes through the origin, which passes through the origin and through the point, and through the point 5 minus 2, 3, and through the point 5 minus 2, 3. Find the equation of a line which passes through the origin and through the point 5 minus 2, 3. Okay. And through the point 5 minus 2, 3. Okay. Here we take the first point x1, y1, z1 is equal to 0, 0, 0. Second point is x2, y2, z2. That is 5 minus 2, 3. First point is origin. Origin is 0, 0, 0. Second point is 5 minus 2, 3. Vector form. In vector form, we write vector A and vector B. What is vector A? 0 I cap plus 0 j cap plus 0 k cap. That is 0 vector. It is 0 vector. And vector B is 5 I cap minus 2 j cap plus 3 k cap, vector B. Then we substitute vector R is equal to, what is the vector form? Vector A plus lambda times vector B minus vector B vector minus A vector. That is 0 I cap plus 0 j cap plus 0 k cap plus lambda times 5 I cap minus 2 j cap plus 3 k cap minus of 0 vector. That will go. So answer is lambda times 5 I cap minus 2 j cap plus 3 k cap. Vector R is equal to. First vector is 0 vector. Clear? So can you write a Cartesian form? Cartesian form. Attendance. Ashita. Ashita. Ahmad Noor. Arjun Manoj. Arjun. Aryan. Aryan. Avril. Burhanuddin. Hasnat. Joshua George. Lakshya Raj. Leah. Luke. Mercy. Mufadal. Nikhil. Nicole. Rachel.
Yes, sir.
Raghav. Raghav. Absent. Raj Krishna. Ranjit.
Present, sir.
Radhi. Radhi. Rima.
Present, sir.
Saad.
Present, sir.
Safia. Tariq.
Present,
Yusuf.
sir.
Okay. Burhanuddin is present, noted. Okay. Absent is, I have noted. Because of examination, I think today many are absent. Okay, so did you complete? Yes. So you have got the Cartesian form. This is the Cartesian form. X minus x1 by x2 minus x1. In 2-point form, you write like this. X minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. Then substitute. X minus 0 by, what is the x2 minus x1 from the above writing? X2 minus x1, 5 minus 0 is equal to y minus 0 by minus 2 minus 0 is equal to z minus 3 by, z minus 0 by z minus 0 by 3 minus 0, which is equal to x by 5 is equal to y by minus 2 is equal to z by 3. This is the Cartesian form, okay? So like this 2-point form, if you get, you can easily write the Cartesian form. 1-point form also, you know how to write the Cartesian form. Any doubt? Now, the next topic is, first topic is over, okay, equations of line. Now, the second topic is angle between two lines. For angle between two lines, we use cos theta formula using dot product. Do you remember cos theta formula using dot product? What is that? A vector dot B vector by magnitude of A vector into magnitude of B vector, okay? So that one, we have equations of lines, that form will be given. Whether it is vector form or Cartesian form, we will use this dot product form to write the angle between two vectors. So that topic we will study next class, okay? So till here, any doubt, children? No doubt, okay? Practice very well. Vector also you have to do well. So I will give you unit test of vectors, okay? Vector unit test I will give you. All of you have studied it very well, right? And DPP is update the DPP so that vector you can easily clear. And with that basic, you can easily do this 3D. 3D today itself or next day, you please try to study this. I will give you the DPP, okay? Today I will give you DPP because we have done the sums. I will give you the daily practice problem. Thank you.